area of a circle. There is a tiny little bit of formula. It's about 4 things I have to write down toward the end. But you guys can handle it. All right, in sets of equivalence. This is the same as this. So I want to find out the area of this trapezium. I've got this trapezium here. I can see that to find the area of a trapezium, all I need to do is to take half of the height of the trapezium, add it to the small length and the long length together. Half the height times the length times and plus that length. That length plus that length. Can you see that?
Yeah.
That length and that length. The long side plus the short side multiplied by half the height. You might have been taught to take the average of the lengths and multiply by the height, but actually it's the same deal, dividing by 2 when you've got 2 things as the average. So you're going to find out the average here and multiply by the height, or you're going to take this length plus this length, and you can see that that is the area of the trapezium. Does it make sense? Yes?
Can we use a ruler to measure it, or how do we?
Why? You don't need numbers.
No.
You don't need to know what the value is. You just need to know how to work it out.
Oh.
So if you did have a value, you could use a ruler to find it.
So we just
Yes.
this is to
Or
understand
from the
the
bottom.
Yeah, it's just about concepts.
Okay.
We're in geometry, guys.
Yeah.
Yes,
It's not
sorry.
maths.
So what age is this at?
What's that?
What age is this?
Oh, maybe 8, 9. 9's a big quite good. What's that?
Yeah.
4 years old.
I'm glad.
3, 2, maybe.
For the 4, understand it. They probably would have to, because always the constructed triangles, they do it for, but just remembering all those concepts is quite hard, and it builds up on quite a lot of maths. I want to show that this area of this little this little what?
Rhombus.
I want to show that it's the same area as that, same height as that, which I can show that these two are the same. True? So I can see these two are the same. So that if these and these equal the same, and this equals this, then this equals that. Is that true?
Yeah.
Yes, cool. Let's see how we go. We've got a idea here that I can make a rectangle. These two are the same?
Yes.
Yes, and I can prove that they're the same because they take up the same amount of space. So, these two are the same?
Yep.
Therefore, these two are the same.
Yeah.
Yes, therefore, the area of this is
Rhombus.
given by the height of the rhombus multiplied by the base. Can you see that's the base?
Yeah.
That's all you need to know.
So it's the same as a rectangle, it's base times height.
But you can't see the vertical
Yeah,
height. So that's advantage. You've seen this just before. I want to find out the area of this triangle. I can easily find out the area of this triangle. Got it? Yep, good. These two are the same area as I've just shown. These two are the same area. Because therefore these two are the same. All good?
I love how well they fit inside.
I do too.
Yeah.
It's beautiful. All right. We start off with our friend Mr. Pentagon. Hello, Mr. Pentagon. And we know that Mr. Pentagon is actually made up of 5/5. True? I take these guys out. You can see that it is the same deal. Yep? So any polygon can be divided into its creative or constructive triangles. Can you see that I did it with a 5? You know I could do it with a 4, and the 3 it's obvious. A triangle is a triangle, so it's made up of triangles, true? I could do with it with a 10. Let's take a 10 here. Let's take a 10 here. Can you see that I've cut this polygon into 10 pieces. Are you okay with that? Are you accepting that this polygon is the same area as 10 times this piece? You agree with that?
Yes.
Good. So, I need to just show you a few more things. I need to show you that the area of this triangle here, I can cut in half and I can create this triangle here. Do you agree that they are the same?
Yes.
Let's just test it out. Do you agree that these are, that's a 10?
Yes.
Right. So here I have got half the height of that triangle, right? But along the bottom here, I have the same length as the base of the triangle. Can you see that if I start walking around, I'm going to walk 10 lots of that distance there? Does that make sense to everybody? And here it is, I've got 10 lots of that base along the bottom. Can you see them? Yep. All make sense? This is half as tall, so we know that the area of this is half, right, is the same as half base times height of this times the number of sides, or the length of side. Okay? Does that make sense to you? Yes? 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 No? This piece here can be found in here. Can you see it in there? Can you see that that's the same piece? Yeah? So I've got 10 of these here. And they're only half as tall. But we've just talked about the area of a triangle, half base times height, right? So I've got half the height, but still the base is still the same. Then multiply that by 10. Would you agree that this and this are the same area?
Yeah.
Yeah? This is given by half the base times the height of the triangles that make up this decagon. Yeah? Almost there, guys. Almost there. Another proof for you to show. Instead of taking half of the height, I could just take half of the base. So this is the same length, right? And I've just cut it into half as long. Here are my 10 triangle pieces. You can see that they're the same. I have 10 of them. Well, this one is cut into half like that, but otherwise you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it? So that there are 10 triangle pieces into this. So this is the same as this. Would you agree with me?
Yes.
Yes? And you would agree with me that this and these three are all the same?
Yes.
You're getting there. Jolly good. In geometry, when we have the height of a triangle, you know, for this triangle here, I need the height of it. The distance between the center of the circle and the midpoint along the edge is called an apothem. Apothem, that's a nice new word. Apothem, got that in it, didn't it? We learned about apothens. So the area of this, I don't need to say base, I don't need to say height anymore. I can say apothem times base. Yes? Apothem times base.
Half.
What's that?
Half of that.
Half of that would give me the area.
Yeah.
Yes, apothem. It's quite a nice little word. Do you remember before when I introduced the circle that it was like the infinite end of the series of polygons? Yeah, like this is only at 10, but if we kept on going, what's going to happen to the length of the base?
Decrease.
Smaller and smaller and smaller until it's almost non-existent. In fact, for all intents and purposes, it is non-existent except it exists. Okay? It's very, very thin. It's infinitely small. However, we have a word for, if I added up all of those tiny, tiny little triangles, right, all the way around a circle, you can imagine it now. If I added them all up, I know how much they all would add up to, what that base would add up to. What would that base add up to? If I add up all of these, I come to the perimeter of the polygon, and we could call it 10 lengths in this case, right? In a circle, we use the word circumference. The circumference, when I add it all up, the length of the circumference is given as
Pi. No.
2 pi r, yes?
Yeah. 3.
2 pi r equals the circumference. Everybody good with that?
Yeah.
So this tells me how far I've got to walk all the way around the outside, or the length that this would be, which is the circumference, right? As this here, we're calling the apothem, right? Not diameter, but radius. As this gets smaller and smaller and smaller, in a circle, the A approaches the radius. Okay? What is my formula for working out the area of a polygon? All polygons, what would I have to do?
Times.
I have to find out the triangle like this. Let's call that an apothem. Let's call it a base. Let's call n equals the number of sides. Is that fair enough?
Yeah.
Yeah.
I'll call this L. L for length. Okay? So n times L equals the perimeter. Is that right? Which is how long that is there? Yes?
Yep.
Half A, or A is the apothem. We've understood that A is the apothem. A is that height. A equals the height. So the area of a polygon is given by half the perimeter, that length, yeah, in L times the apothem. Yes? Well, good. Let's do a little bit of a substitution here. We know that A tends to R. So that you're okay if I put in an R in there? When it gets closer and closer to a circle, the apothem becomes the radius. The radius is given by the distance from the central point of any of the points around the circle, right? Very, very narrow. You don't need to teach this to all 8-year-olds. Some are interested. The circumference is NL. Remember, if there are 10, let's call them 2 centimetres, then 10 times 2 would be how long that perimeter is. So this here is the circumference. Do you understand that? NL is the same as circumference. So okay, if I put in NL, I can put in 2 pi r. You comfortable with that? That's 2 pi r here. It's the same.
Half of that is just by
Half of that equals. We cancel out that half and half there. There we've got pi r times r, which is pi r squared. The area of a circle is given as pi r squared.
So I learned the formula, not pi, but I was told the area of the circle is pi r squared. This is pi. Find the radius.
Yeah.
Find the area of the circle.
Here's a few worksheets.
Yeah.
Should we tell kids that story? Why?
If they're interested in it.
It's a pretty interesting story.
Why?
Because it's like the background to the outcome. It's the history to the outcome.
It's understanding why you're doing it as well. Like, what's the point?
That's what maths always seems like. You just did things, you know, didn't know why.
Yeah.
When I inscribed the circle and the square before, we knew that this radius is r. What is the area of this whole square? Can you see that that's r squared down there?
So it's
And that
4
there's
pi
like
r.
4 r squareds. Can you see the area of the square equals 4r squared? Shoot.
4 r squared.
And the area of the circle we know is always pi r squared.
Oh, yes.
So I asked you, well, what is this area here? And basically I've got 4 lots of r squared minus 3.14 lots of r squared. So that area of this scribble
With the
bit
difference.
here is about 4 minus pi, which is approximately equal to 1. Which means that it's, yeah, it shows that relationship. How's that?